Good day, students. On this clip, we're going to be going over 8 examples on how to evaluate log expressions, all right? So before we start with the examples, we are going to go over 3 key formulas that we're going to be using for evaluating the following expressions. Okay, the first two are known as the inverse properties of logarithm, inverse properties. Now the first one is log base b of b to the x power equals x. So what happens here is if the base of the logarithm and the argument of the logarithm match, they cancel each other out and you're left with the exponent, okay? And then the second inverse property is a raised to the log base a of x equals x, okay? So if you exponentiate a logarithm with a certain base and using the same base as the basis of exponentiation, this base of the exponent and the base of the logarithm along with the logarithmic function cancel out, and you're just left with the argument of the logarithmic exponent. Okay? Alright, the other property we're going to use is the power property of logarithms. Okay, power property. So the power property basically is if you have n log base b of a, this coefficient of logarithm can be expressed as the power of the argument of the logarithm. So this can be written as log base b of a to the n. It says do your powering up. Okay, this coefficient can become the exponent of the logarithmic argument. All right, so these are the 3 formulas I'm going to be using to evaluate the following logarithmic expressions. Okay, so let's write down the instruction for the notes. So we're going to evaluate the following expressions. All right, so question number 1, we have the problem log base 3 of 9. Okay, so the goal here is to make the base identical with the argument. Okay, we can change the argument, but we cannot change the base. So the question is 3 to the what power gives me 9? Okay, can I find a power of 3 that gives me 9? Absolutely. Think about it, 3 to the second power equals 9. So the goal always is to express the argument as a power of the base. Okay, so this can be written as log base 3 of 3 to the second power. Okay, I substituted 3 squared with 9. Okay, so the goal is for the base of the logarithm and the argument of the logarithm to match, and that's the case here. So using the inverse property of logarithms, these two cancel out, and you're left with 2. Okay, so that goes your answer. All right, moving along to question 2. What is log base 4 of 1 over 16? Okay, so this number right here is the argument of the log. This is the base. I have to express 1 over 16 as a power of 4. So how do I do that? Well, let's start with 16 first. I know that 4 to the second power equals 16, right? 4 to the second power equals 16. So I can write this as log base 4 of 1 over 4 to the second power. Okay? Now, what is 1 to the second power? 1 to the second power is also 1. So in this case, I can write this as log base 4 of 1 square over 4 square. Okay? And then using the quotient property of exponents, I can factor out the powers and write this as log base 4 of 1 over 4 square. Okay? Now the last step involves me reciprocating this fraction I have right here. I'm going to reciprocate this, so this is going to become log base 4 of 4 4 over 1 square. Okay, I can write 4 over 1 as just 4, so this I can just write as log base 4 of 4 to the negative 2. Okay, this power right here is supposed to be negative 2. When you reciprocate, you switch the sign of the power, right? So this becomes negative 2. So we have log base 4. When I flip this fraction over, I had log base 4 of 4 to the negative 2. So now these are identical. So these two cancel out. And your final answer is negative 2. Okay? Now that's one way of doing it. Another way of doing it, let me do it here, method 2. Method 2 is a little bit quicker. If I have log base 4 of 1 over 16, I can just write this as log base 4 of 16 to the negative 1. Just reciprocate that. And then I'll express, since 16 is 4 squared, this is going to be log base 4 of 4 squared to the negative 1. Okay? And then that becomes log base 4, using the product property of exponents. Power of a power property of exponents, you have 4 to the negative 2, and then these two fours, these cancel out using the inverse property, and our answer is also negative 2. Okay? So those are two different ways of doing it. All right, let's move on to question number 3. What if we had the question, find log base 3 of 27. Okay? Note, you can never change the base, you can only express it. So I want to express 27 as a power of 3. So I know that 3 to the third power is what? 27, right? So this becomes log base 3 of 3 to the third. Now these two are identical, the argument and the base of the logarithm, so they cancel each other out. Final answer is 3. All right, number 4. What if we have 9 raised to the log base 3 of 5? So the goal here is I want this number to match the base of the logarithm. So I need to express 9 as a power of 3. I know that 3 squared equals 9. So I'm going to write 3 squared. This square becomes a multiple of the power log base 3 of 5. Okay? And then this square, I can use the power property to power up this square right here. So this expression becomes 3 raised to the log base 3 of 5 squared. Now the base of this exponent and the base of this logarithm are identical, so they can cancel out. And you're left with 5 squared, which equals 25. There goes your answer. All right? Okay, moving right along, question number 5. Want to evaluate the expression log base 8 of 2. All right? So remember, you can't change the base, only the argument, so I need to express 2 as a power of 8. Okay? That's a little bit difficult. 2 to the what power equals 8? So to do this, I know that, I'm sorry, we're supposed to switch it around. I need to express 8 as a power of 2, right? So 8 to the what power equals 2, right? And now that's what I'll replace 2 with. So I don't know what this is off the top of my head, so let's do it step by step. I know that 2 to the third power is 8, right? So what does that tell me? There's a clue I can use here. I need to get rid of this power. And if I can isolate 2 here, whatever this expression is, it will be a power of 8, and it will be equal to 2. So to do that, what I'll do is I'll raise both sides to the 1/3 power. Why did I pick 1/3? Because 3 is a power of 2, and I need a reciprocal of this exponent right here. Okay? See what happens? If I use the product property of exponents, these two powers cancel out. I'm sorry, use the power of a power property of exponents, so you're left with 2 equals 8 to the 1/3. So that's exactly what we need. 8 to the 1/3 is 2. So this becomes log base 8 of 8 to the 1/3. So we have accomplished our goal of making the base and the argument of the logarithm identical. So these two cancel out, and your final answer is 1/3. Okay? Alright. Alright, moving along, question number 6. What if we have, put this one in it. we have log base 8 of 4. Okay, we want to simplify this expression. Now, for this one, we have to express 4 as a power of 8. So basically, the question we're asking ourselves is, what power can I raise 8 to get 4? Okay, remember this, the base doesn't change, the argument has to change. So 8 to what power equals 4? Okay, that's a very difficult problem to figure out, but if we write it as exponents in exponential form, it'll be pretty easy. So we break down 8. 8 is 2 to the third, and then we know that 4 is just 2 squared. Okay? So in order to make these two equal, what power must I raise this exponent to make it 2? So all I just need to do is I need the power that will first of all get rid of the 3, which is by dividing it by 3, and then I'll make it a 2. You put a 2 there. So 2 over 3, because I know that if I multiply 3 by 2 over 3, that gives me 2. Okay? So just figure out some reciprocate the numerator and the desired power you want to put it on top. Okay? So this is exactly what I need. So this tells me that 8 to the 2/3 power equals 4, based on this equation that we have right here. Okay? So this problem is going to become log base 8 of 8 to the 2/3 power. All right? Now that the base and the argument are identical, they cancel out, and then you're left with 2 over 3 as your final answer. All right? Okay, now let's take a look at number 7. What if we had log base the square root of 2 of 2? Okay, now for this one, I need to express 2 as a power of root 2. Okay, so this question I'm going to ask myself, the square root of 2 raised to what power will give me 2? So I know that this is a square root, so the inverse of square root is square. And I know if I square the square root, this square root and the 2 cancel out, this and this cancel out, and that just gives me 2. Okay, so if I want to express 2 as a power over 2, I'll just write it as log base root 2 equals root 2 raised to the second power. Okay, the goal here again is to make the argument of your log and the base identical, and that's the case here. They're identical, so these two cancel out, and your final answer is 2. Alright, let's try one more problem, and that'll be that, question 8. What is log base 27 of 9? The goal here is to express 9 as a power of 27. So the question is, 27 to what power is 9? So 27 to what power is 9? Well, this is hard. If I express them as in exponential form, probably that'll be easier. Okay, 27 is 3 to the third, and 9 is 3 squared. So what power can I raise 3 to the third to change this power from 3 to a 2? Similar to the other one we did, right? So I first of all need to divide it by 3. So these cancel out, and put a 2 there, so that becomes square. Okay, so this 3 to the third raised to the 2/3 power is 2. Using the power of a power property of logarithm of exponents, we can see that that's the case. Alright, so this expression tells me that 27 raised to the 2/3 power is 3 to the second power. Alright, exactly what we're looking for. So this problem is going to be log base 27 of 27 to the 2/3 power. Alright, the base and the argument are identical, so they both cancel each other out. And your final answer is 2 over 3. Alright, so that's that. So thanks so much for taking the time to watch this video. Feel free to subscribe to my channel just by clicking up here. You can also share the contents of this video with your friends via Facebook or Twitter. More videos can be found on minecraftserve.com. Thanks again and have a wonderful day.